Today in this lesson, I will explain the nomenclature of organic compounds. So, the nomenclature of alkanes, alkene, and alkynes. So, first of all, the basic naming system or nomenclature. Basically, a compound is composed of three parts. Number one part is called prefix, and the second part is called parent, and the third part is called suffix. Every part basically give us the specific information. So when we talk about the prefix basically tell us where our substituent located, or the we can also call that where are the branches located. And the parent part basically tell us how many carbon atoms are there in a molecule, and the suffix basically it tells us what family does the molecule belongs to, or we can also call this one that it tell us the functional group, or the homologous series of the compound. So first thing, the naming of alkanes. So how we give the name, even alkanes also have these three parts. Okay, here I will just eliminate this prefix. Let's suppose we have compound which do not have any substituent, so we will only focus on the two parts, that is parent and the suffix. Okay, so first I will tell you what is the suffix of alkanes. For the suffix, we the alkanes have the suffix of ane, so you can also give this name from the alkane, ane. Okay, now the second parent part, basically it based on the number of carbon in the longest continuous chain. So we need to memorize some numbering. For example, when we have one carbon, so parent name will be meth, and if I just combine this meth with ane, so the complete name becomes methane. Similarly, let's suppose in a longest continuous chain we have six carbon, so the name will become hexane. So right now I'm just telling you the organic compound, or we can say the alkanes, which uh, are the simple chains which do not have any branches. Okay, moving forward. So this is the first example of the state chain of alkane. Now you can see it is written CH3, CH2, CH3. So how many carbon you can see? There are three carbon. So the parent name will be prop, and the suffix will be ane. So name will be propane. Okay, now remember one thing here, that this one is a state chain and it doesn't have any branch. So we can also call this one as N propane. Okay, let me show you another example. Okay, now this example, basically this one is a zigzag line. So this representation of our organic compound is different than the first one. So let me tell you one thing here. This first representation in which we have this CH3, CH2, CH3 thing, this representation is called as condense formula. This one is condense formula, and that one is called skeleton formula. Okay, so we need to understand how we can count the number of carbon in the skeleton formula. Remember that every corner, even the every terminal, this one is the terminal, this one, and this one is corners, corner number 2, this one corner number 3, this one is the terminal, second terminal. Okay, so every corner basically it means it, this one is carbon. So we have one carbon, the second carbon, third carbon, and the fourth carbon, and this single line basically tells us there is a single bond between each carbon. So this one is alkane because every carbon have a single bond between them. So how many carbon are there? There are four carbons. So according to the four carbon, the parent name will be but, and the suffix will be butane. Okay, let me give you another example. Okay, another thing, sorry, it should be named as n butane because it doesn't have any branch. Okay, moving forward to another example. Now this one is another representation. So this one is called displayed formula. This one is called displayed formula because everything, every molecule or and every atom is expanded way. So this is called the displayed formula. So remember that the molecule can be in the form of condensed formula or a skeleton formula and the displayed formula. We do not find any difficulty to count the number of carbon and hydrogen when we have a condensed formula and the displayed formula. But skeleton formula is easy to draw. So only one thing we have to remember, that every corner or the terminal basically represents the carbon. Okay, now moving toward this example. So first I will count the number of carbon: 1, 2, 3, 4, 5, 6, 7. So there are 7 carbon and every carbon has a single bond. So it must be alkane, and the parent name will be hept, and the suffix will be ane. So, or we can say complete name will be n-heptane. So this is the way we can name the simple alkanes which do not have any substituent or branch. Okay, now talks about the alkane with single substituent or branch. So there are few steps we have to follow. Step number one: select the longest carbon chain and identify the branch and the substituent. And the second step, number the carbon atom in the main chain, begin at the end near to the first branch point. Okay, so basically we have to give the number to the specific carbon, and we will start the numbering from where the branch is near. Let me show you with an example. Okay, we have to follow the third rule as well. Third rule is the same, that name the main chain, parent, the suffix. Find the longest continuous chain. Okay, we already know this one is the third step. Let me explain these 3 points with respect to an example. So let's suppose we have CH3, CH, CH3, CH3, sorry, CH3, and here another CH3 is there. Okay, now first step, select the longest carbon chain and identify the branch. Okay, so to select the carbon chain, let's suppose I'm starting from here. Now right now this compound has 3 terminals. This one is the first. Let me identify the terminals. This one is the second, and that one is the third terminal. Okay, how I will able to identify the longest carbon chain? I have to combine at least 2 terminals, and whenever I combine, and I must get the longest carbon chain. Let's suppose if I just combine in a straight way, in this way, so how many carbon I am getting? 1, 2, 3, 4. So in this way I am getting 4 carbon. So I can also connect this first carbon with the second terminal carbon. So if I do, so how many carbon I will get? Let me show you in the shortest way. Let's suppose we have this kind of condition. Okay, so when I connect the first carbon with the second carbon, so how many carbon I am getting? 1, 2, 3. So in the first example, you can see when I just combine the first carbon with the third one, how many carbon I got? In the longest, there are 4. But in the second time, when I connect the first carbon with the second, how many carbon I got? 3 carbon. So according to this selection is not correct. This one is correct. Okay. Now after the selection or identification of the longest carbon chain, I have to identify the branch. Okay, the remaining part, this part will be named as a branch. So this is the first step. Now you can understand if you just read it. The select the longest carbon chain and identify the branch or the substance. Okay, now the second step, the number the carbon atom in a main chain, begin at the end nearer the first branch point. Okay, now let me show you something here. Now first thing, we will select the longest carbon chain, and then we will identify the branch. Okay, here I can start numbering from the left hand side: 1, 2, 3, 4, or I can start the numbering from the right hand side. So it will be 1, 2, 3, 4. Okay, in my first numbering, what I get, the branch is attached to the second number carbon. But when I start numbering from the right hand side, the branch is connected with the third number carbon. So according to the rule, that I will select the numbering from where the branch should be near. So I will select the numbering from the left hand side. So this numbering is not correct. So now by this I am able to undergo this step number 2. Okay, now I will just use the main formula. What was the main formula? That I have to just give the name of the branch. Okay, here now remember that this branch CH3 has a specific name which we call as methyl. Okay, why I'm just identify this one as methyl? If you do remember, it only has one carbon, and because of lack of one hydrogen, so I will just add the name in meth yl. So it could be C2H5 sometime, so it becomes ethyl. So these are the most common branches I have just written. Okay, now starting with the name, the first I will just write down the number of the carbon where the branch is located, that is 2, and after that I will just name this branch, it is methyl. So it will become 2 methyl, and after that I will just give the name of the parent. How many carbon are there? 4. So 4 carbon I will write but, and the suffix, as it is alkane, it will be ane. Now you got my point. Let me show you another example. Let's suppose we have another example. Now this is the skeleton formula. So first I will select the longest carbon chain. This one is the, let's suppose, first carbon, this one is the second, this one is the third, this one is the fourth, and this one is the fifth carbon. So longest carbon chain will be like this. Okay, the rest of the part, this part will be as identify as branch. Now in this branch part, you can see it has one corner and one terminal, so it must have 2 carbon. So branch will be C2H5. So name of the branch will be ethyl, because it contain 2 carbon. Okay, moving forward, if you do remember how I will give the name, first I will just write down the numbering of the branch. Okay, now you can see this branch is connected with the carbon number 3. So first I will write 3, and the name of the branch is ethyl. After that I will write the parent name. How many carbon are in the longest chain? There are 5. So the for 5 I will write pent, and the suffix, as it is an example of alkane, so suffix will be ane. So complete name will be 3-ethyl pentane. Moving forward, let's suppose this is another example. So first I will select the longest carbon chain. This will be the longest carbon chain because it has how many carbon? 1, 2, 3, 4, 5, 6, and this will become a branch. Okay, so what do you think? Where should I start the numbering, from the left hand side or the right hand side? Okay, so if I start numbering from the right hand side, 1, 2, 3, 4, 5, 6. So I'm getting the branch on carbon number 5. Or if I just start the numbering from the left hand side, 1, 2. So you can clearly see I'm getting the branch on the second number carbon. So it means this numbering is not correct. So according to this numbering, let me complete this numbering. The branch, that is CH3, is located on the carbon number 2. So first I will write 2, and the branch name is, because it is CH3, methyl, and we have 6 carbon. So 6 carbon has a specific name, that is hex, and the suffix will be ane. Now this one is the example. Now you can see I have already numbered it. This one is the carbon number 1. The blue part is the longest carbon chain, and the red part is basically branch. Okay, right now I'm just giving you the example which has more than one substituent. So if I just select the longest carbon chain, so longest carbon chain will be like this. So this is the longest carbon chain, and numbering will start from the left hand side because this branch is uh, coming near to the left hand side. And okay, we have another branch, that is CH3. Okay, when we just focus on the numbering, now you can see this one is carbon number 1, this one is carbon number 2, and this one is the carbon number 3. Okay, both the branches are located at carbon number 3. So how I can just name this compound? So I have to follow another rule here. If two or more identical substituents are present, so use one of these prefixes, that is di. Okay, remember that when we have two identical, so we will use two di. For three identical, we will use tri, and for four identical, we will use tetra. Okay, now I will just give the name to this compound. The name of this compound will be 3 comma 3. Okay, why I'm writing 3 comma 3? Because we have two branches and both have the both are located at carbon number 3, so I have to write the number two times. Then I will write di because they are two identical, and the name will be dimethyl. And after it, you can see how many carbon in the longest carbon chain. There are six, so I will write hexane. Okay, now the next rule: if two or more different substituent groups are present, cite them in alphabetical order. So this is the another example. Now you can see I have already selected the longest carbon chain, which is the bluest part here. Now you can see clearly. Now we have two branches. This is branch number 1, and this one is branch number 2. Both are located at the carbon number 3, you can clearly see, but both the branches are different. Okay, now this branch composed of only one carbon, so I will name this branch as methyl. And the upper branch, basically it is composed of two carbon, so the name will be ethyl. So how I will just name these branches? Remember that if two or more different substituent or branches are present, to cite them in alphabetical order. So according to alphabetically, the ethyl name should come first. So first I will write the number of this branch, that is it is located on the carbon number 3. So I will write 3 ethyl, and after that I will write 3 methyl. I have to give number to each substituent or branch, and then when done with the numbering and the naming of the branches or substituents, so then I will write the name of the main parent, that is there are 6 carbons, so it will be hex, and the suffix will be ane. So this is the way I am able to name the branch alkanes. Okay, now let's talk about the naming of cyclic alkanes. So we have some additional rules. So number one rule is the ring is the always main chain. So right now you can see this is the ring. So this will be considered as the main chain. The second rule, the prefix cyclo is added to the name of the main chain. So previously, as we were using pentane or hexane, so now we will use cyclopentane or cyclohexane. Now the next rule, if only one branch is, it doesn't need to be numbered. And the fourth, if more than one branch, number the carbon in the ring to get the lowest combination of the numbers of the branch location. This one is carbon number 1, this one is carbon number 2, this one is carbon number 3, this one is carbon number 4, and this one is carbon number 5. So this ring will be the main chain, and the rest of the part, this one and that one, will be considered as branch or substituent. So right now we have two branches. So this is the third rule: if only one branch, it doesn't need to be numbered, but we have two branches, so we will give the numbers. Okay, so how we will give the numbers? This rule will going to tell us. if more than one branch number the carbon in the ring to get the lowest combination. Okay, if I just start numbering from the clockwise direction, as I already did, 1 2 3 4 5, so I'm getting the combination of branches, that is 1 and 5. Now you can clearly see, on the 1 number carbon I have this branch, and on the 5 number carbon I have that branch. But let's suppose if I start the numbering from the counterclockwise. So this will be the carbon number 1, this will be the carbon number 2, this will be the carbon number 3, this will be the carbon number 4, this will be the carbon number 5. So what I'm getting the branches on carbon number 1 and 2. So what do you think, if I just follow this, if I want to follow this rule, so which combination should I use, this one or that one? So basically I will use this combination, this will be incorrect. Okay, now I will give the name. First I have to identify the branches. Now as you know, this one is the skeleton formula, only the single terminal is there, so it must be CH3. This one has a corner and a terminal, so it must compose of two carbons, so it will be C2H5, and the name of the C2H5 is ethyl, name of the CH3 is methyl. Alphabetically the ethyl name will come first along with its number. So first I will write 2 ethyl, and after it I will write 1 methyl. So now the substituent name and the location is already written, so I will move toward the name of the parent. So if you do remember, in the second rule, the now I will add this cyclo prefix to the parent name. I have only 5 carbons, so the name, parent name will be pent, but after addition of this cyclo it will becomes cyclopent. And as it is alkane, so the complete the name becomes cyclopentane. So this is the way we will able to name the cyclic alkanes. Okay, now let's talk about the naming of alkenes and alkynes. We have very similar rule as for the alkanes, but we have additional rule. This is the simple example. This one is the basically displayed formula, and this one is the skeleton formula. Basically both are the same. Now you can see in the skeleton formula or in the displayed formula, when we see this double line, it means this one is alkene. So how we will name this? So let me show you the additional rule. So we will choose the longest chain that contain the double or triple bond. So now I have to number this carbon chain, and when I want to number this carbon chain, I have to number where the double or triple bond is near. So if I do remember, if I start numbering from the left hand side, this one is carbon number 1 2 3 4 5. So I'm getting the double bond on carbon number 3. But if I start numbering from the right hand side, 1 2 3 4 5, then I am getting the carbon double bond or double bond on carbon number 2. So I will just prefer this numbering. This will be uh, incorrect numbering. So I will start numbering from the right hand side. So I just followed this rule, the choose the longest chain that contains the double or triple bond. Okay, now so if we do remember, previously we were using the suffix as alkane, but now for alkene we will use ene. And the next rule, let's suppose if we have alkyne, so we will use wine. And the last rule, include the number with the parent, indicate with the carbon double or triple bond, as I on the start on. Okay, I've already mentioned I have to include this number also. So what will be the name? The name will be 2, and as we have 5 carbon, 2 pentene. So this 2 basically is giving us the location of the double bond. Okay, now I will show you the example of branch alkyne. So we will just able to understand how to name the alkyne. Now this one is the basically condensed formula, and this one is the similar. Basically it is the skeleton form. Both are the same compound. So first what I will do, I will just select the longest carbon chain, and remember that whenever I select the longest carbon chain, it should include that carbon triple bond. I cannot do the selection in this way. this selection will be wrong because it doesn't contains this carbon carbon triple bond. So I will do the selection which should contain this carbon triple bond or double bond, or we can say in the future maybe we are dealing with the different functional group. So remember that the functional group should be included in the uh, carbon longest carbon chain. So right now I will do the selection in this way, and this will be identified as a substituent or a branch. Okay, now how I will give the numbering. So numbering will be the same way that I will just give the numbering starting where the this alkynes carbon carbon triple bond is near. Now here you can see if I can do the numbering from the left hand side, 1 2 3 4. So by doing this I am getting this branch on carbon number 2. This is the branch position, and the triple bond carbon carbon triple bond I'm getting on the carbon number 3. But I will start numbering from the right hand side, this 1 2 3 4. So I'm getting the carbon carbon triple bond on carbon number 1. Okay, triple bond on carbon number 1, and the branch on carbon number 3. Now you can see this branch is on carbon number 3. So remember that whenever this kind of condition that the branch is far but the main group is near, so I will prefer the main group but not the branch. So this numbering is not correct. I will follow this numbering. So according to this numbering, if I just repeat that the branch is on carbon number 3, so I will write 3 methyl, because I will start with the name with the number of the numbering of the branch and the name of the branch. So this is 3 methyl, and after that I will write the location of carbon triple, that is 1, and it is 4 membered ring, sorry, not ring, straight chain. So it will be but, and as it is carbon carbon triple bond, then I will use the suffix as y and e. So this one is the another example here. Now this one, in this example you can see the carbon carbon double bond is also there and carbon carbon triple bond is also there. So remember that I will select the longest carbon chain which should include these two functional group, and this will be the branch. So now here very interesting thing is there that if I start numbering from the left hand side, 1 2 3 4 5. So I'm getting the carbon number double bond on carbon number 1 but the triple bond on carbon number 4. But if I start the numbering from the right hand side, so this will be the carbon number 1 2 3 4 and 5. I'm getting the carbon carbon triple bond on carbon number 1 and the carbon carbon double bond on carbon number 4. So both basically when I'm doing the numbering, the carbon carbon double bond and carbon carbon triple bond both are at identical position, both are at same position when I'm changing. So whenever this kind of case, this is the special case, so we will prefer the numbering from the left hand side where the carbon carbon double bond is near. The reason is that the carbon carbon double bond is more reactive than carbon carbon triple bond. So this numbering will be correct and this will be wrong. Okay, if you do remember another thing here, we have a branch as well. So this branch is numbering is 3. So first we will write the name of the branch as well as position, that is 3 methyl. And after that what I will write the location of carbon double bond. It will be 1, and there are 5 carbon, so it will be 1 pentene. Okay, what one thing is left, that is the where is the carbon carbon triple bond. So it was on the carbon number 4, so I can write this thing in this way, 4 wine. Moving forward. Okay, now this is the example of cyclic alkene. So how we will just number it. So remember that this cyclic alkene contains 2 double bond and 1 branch. This is the branch. So this branch is composed of 1 corner and the terminal. So it must be C2H5, and the name will be ethyl. So I will start the numbering where the double bond is near. So I will start numbering from here, 1 2 3 4 5 six. If you do remember, so I will always give the preference to the double bond instead of the branch. Okay, now what will be the name of this compound? The name of this compound will be 5-ethyl, and after that I will write the location of carbon carbon double bond. This one, look, they are located all the carbon number 1 and carbon number 3. So I will write 1 comma 3, and after that this one is the cyclic compound, so I will write cyclo, and there are 6 carbon in the ring, so I will write cyclo hex, and as we have two identical double bonds, so I will write diene. So why I written this die? The reason is that it has two identical double bond in the ring. So this is the complete now of this compound. So this was the lesson. That in this lesson I have already explained all the possible naming of alkene, alkene, and alkyne along with the cyclic compounds. So if you do remember all these rules, so you will able to give the name around 80 to 90% of the hydrocarbon, because all the main rules are the same. Thank you.